look at the social factors in play. Okay, there was a big drive by the UN, to deal with dangerous anthropogenic climate change. Again, this was a 1992 treaty before we even had any evidence of human-caused warming at all. Okay, and then you had scientists become invested in this, in their career goals and the funding that comes into the field and all of this kind of stuff. There was this sort of social contract between the scientists and the policymakers that perpetuated this situation, and and they were the policymakers. We need more. We need more and more confident statements from the IPCC, even though the dimensions of the problem were growing and growing and growing every year, and clearly becoming more complex and obvious that there were a lot of things that we didn't understand.
Well, it's not as if the IPCC documents themselves are even that radical. I mean, my understanding of the IPCC documents is that the projection is something like 1 to 2 degrees of further warming, with some increase in variability, especially in the polar regions, and a small degree of sea level rise. No indication in the IPCC reports that this will produce runaway, out-of-control feedback loops that will have a devastating consequence. No real vision of apocalypse. And so
that's not quite correct. Until recently, people were looking at projections of 4 to 5 degrees centigrade more warming over the course of the 21st century. Okay, the issue was wildly ridiculous emissions projections, which are now believed to be implausible. The more recent IPCC assessment report with more plausible emissions scenarios is looking at more 2 to 3 degrees centigrade of warming. And we've already had 1 degree, so it's an additional 1 to 2 degrees centigrade of warming that people expect based on the climate models. So they were pretty alarming up until recently, because everyone was focused on this extreme emissions scenario, which is now widely accepted as implausible, if not impossible. So there was a lot of alarm, and all the, when you talk about all the projections of extreme weather events, and we won't be able to grow wine in California, and crazy projections of sea level rise, all these projections were tied to that extreme emissions scenario. And it's taken the community a long time to reject it. In fact, this extreme emissions scenario was still the most widely used in the 6th assessment report, which was published only like 2 years ago. So, I mean, this is still pervasive, these excessively alarming projections of what could happen in the 21st century, mostly driven by implausible to impossible emission scenario, but also driven by climate models that are running too hot.
Okay, let's go into that a bit. So I talked to Richard Lindzen about a week ago about the problems with models. He said, for example, that the models are based on cells, let's say, so those would be, the whole Earth can't be modeled, so you have to oversimplify it. You have to clump it into chunks, and the chunks are about 70 miles wide. They can't really model cloud activity very well. There's a lot of error in relationship to projecting and forecasting the effect of water vapor. The models have to build a lot of assumptions in, and that doesn't mean that we shouldn't build models, but it does mean that they have very large potential for error, and that error is magnified as you project out into the future. And so I've read, for example, you tell me if you think this is accurate, that our estimates of the cumulative effect of carbon dioxide on global warming or climate change are smaller than our estimates of the magnitude of our error in measuring the effect of water vapor. And that's a big problem, because water vapor is a major contributor to warming in principle. And so if carbon dioxide effects are under the size of the error in that measurement, that's really, Well,
I wouldn't put it that way. We have a pretty good idea of how much water vapor is in the atmosphere. The question is, how is that going to change with warming? The bigger issue is the clouds, what clouds are doing. Clouds have a huge, and they're not modeled very well, and the observational basis for understanding how they're trending, only goes back a few decades. So, that's a tough one. But the net result of these uncertainties in water vapor and cloud feedback is that we don't know how sensitive the climate is to increasing CO2. because the way the models treat it is that CO2 and clouds amplify the warming. And I think the cloud feedback might even be negative. Water vapor does overall amplify the warming, but in the tropics, where Richard Lindzen has done his research, he proposes that there is a negative feedback, and that's something that's hotly debated. But I think the clouds are the bigger issue. But apart from what's going on in the atmosphere, to me, it's really the oceans and the sun that are the biggest sources of uncertainty in terms of understanding what's going on and be able to project into the future. So there are...
Okay, why the oceans?
Oh my goodness. Okay, the oceans have these large circulation systems overturning. Okay, El Nino, La Nina, people are familiar with that. That's a mode of natural internal variability. There's also decadal and multi-decadal oscillation cycles that change the patterns of clouds, the whole patterns of sea surface temperature, influence the snowfall on Greenland, the Arctic sea ice, rainfall, regional climates, etc. And the models don't treat these very good. Well, there's a whole spectrum of these ocean circulations all on out to 10,000 years. You have millennial scale overturning that influences the climate, and the models have far too little power, in that part of the spectrum. So we're just missing that. And then
and so is that a consequence? Does that mean that the degree to which the ocean takes up carbon dioxide is permeated by error in measurement? Is it also an indication of our lack of understanding of how the temperature of the ocean itself is regulated by the motion of water from the depths up to the top? All of that?
Oh, yeah.
Is that where the error is?
Well, no, vertical transport of heat and carbon in the ocean is part of the consequences of the uncertainty in these large-scale circulations. But more fundamentally, these large-scale, they change the weather patterns and change the clouds, among other things. So, this is trying to get all that modeled right, let alone making credible predictions into the future. We're not there. I mean, not even close to being there. Okay, and then once you get into the sun, it's even, crazier. I mean, the IPCC has pretty much dismissed the role of the sun, in the last 150 years. But the interesting thing is that in the Sixth Assessment Report, Chapter 6, they finally acknowledged the great uncertainty in the amount of solar forcing in the late 20th century. And this arises from, there was a gap in the satellites measuring the sun output that occur at the time of the Challenger shuttle disaster, if you recall that. And so one solar sensor was running out, and they were supposed to launch another one, but all the launches were put off for a number of years until they sorted out what was going on at NASA with the launches and everything. So there's this so-called gap, and depending on what was actually happening in that gap, you can tune the solar variability to high variability or low variability. So all the climate models are being run with low solar variability forcing, but for the first time, Chapter 2 in the observational chapter of the Sixth Assessment Report acknowledged this issue, that there is huge amount of variability. And this doesn't even factor in the so-called solar indirect effects in terms of, it's not just the heat from the sun, there's a lot of issues related to ultraviolet and stratosphere and cosmic rays and magnetic fields and all these other things that really aren't being factored in. They're at the forefront of research, but they're certainly not factored into the climate models. So there are so many uncertainties out there that affect certainly the projections of what might happen in the 21st century, but also our interpretation of what's been going on with the climate for the last 100 years ago and exactly what's been causing what.
Well, so I would say that those who object to the line of reasoning that you're putting forward, I believe, would make an argument analogous to the following. They would say, well, look, we have, despite all the objections on the measurement front, we have pretty good evidence that there's a warming trend. We have reasonable evidence that at least a reasonable proportion of that is a consequence of anthropogenic activity, most particularly the production of carbon dioxide. The potential consequence of this could be apocalyptic 100 years down the road or 50 years down the road. Even with all those doubts in mind, it's incumbent upon us to take something like emergency action now so that we ameliorate this risk of apocalyptic transformation. And so this is just obstructionist hand-waving your objections, and if you were moral and on board, you'd see that this issue is so serious and so apocalyptic that it's inappropriate to stand in the way of the amelioration. And so what do you think about that as a counter proposition?
Okay, the weakest part of their argument is whether all this is dangerous. The sea level rise is, creeping up. The ice cap, Greenland, Antarctic, it changes from year to year with a little bit of melting, but there's no catastrophe looming on those fronts, and so they've turned to extreme weather. Oh, global warming is calling, and I have to say the hurricane and global warming first put this idea into their head. If we can show that even 1 degree can cause something bad like more Category 5 hurricanes, then we have something. So this started this whole trend of every extreme weather event is associated with human-caused global warming, which just isn't true.
Right.
And if you look back, and they tend to go back to 1970 or 1950, this is the warmest year, the worst storm, or the biggest drought, or whatever, since 1970, maybe since 1950. But if you look to the first half of the 20th century, the weather was way worse, certainly in North America and over much of the globe also. Right now, in the U.S. West, we're being assaulted by these atmospheric river events, bringing huge amounts of rain and snow, which is going to cause flooding. It's still snow yet. And, this is horrible, global warming and everything like that. But if you go back to the winter of 1861 and 1862, 15 inches of rain fell in central California over a period of a couple of months, which huge floods over a very widespread area that lasted for absolute months. Okay, and paleoclimate evidence showed that these tend to happen about every 200 years or so, where you have this massive accumulation of these atmospheric rivers. So this is nothing at all unusual. So if you look back into the historical record, or better yet, the paleoclimate record, invariably you will find worse weather events. So
that's part of the time frame problem, right? Is like, well, over what span do you evaluate these events before you draw your conclusions? And
but you can't.
So do you believe that any of the tipping point hypotheses? Franzen told me something interesting. This was kind of a technical proposition. He said that in complex systems with many degrees of freedom on the entropy front, so many ways they can potentially react, the probability of a tipping point positive feedback loop, like the runaway global warming or something like that, the melting of the Greenland ice caps because we hit a tipping point, said in complex systems that have multiple potential outcomes, that kind of all or none tipping point is unlikely. You get that more likely in a simple system that's characterized by the probability of radical state change, like water freezing, for example. And so I thought that I can't evaluate that argument. It's outside of my domain of scientific competence, but it struck me as an interesting idea.
Well, to some extent, it's true. There is one sort of tipping point that we could encounter, and if this does happen, I would expect that human-caused global warming would play only a small part, and this is the West Antarctic ice sheet, which is an unstable ice sheet. So if you took the ice sheet away, the continent would actually be underwater. But what it is, you have this huge ice sheet that sits on the continent, and part of it's above water. Okay, and it has an overhang. And and this is just a dynamically unstable situation, and it moves fairly fast. Underneath this ice sheet are lots of inactive volcanoes, even the occasional active volcano. So if these volcanoes became active and we had, a greater heat source under this, combined with sea level rise and a little bit of global warming, this could accelerate. And on the time scale of, 3 or 4 centuries, we could see this collapse, which could lead to a substantial sea level rise. So that's the one kind of, if we saw that happening, are there engineering ways of dealing with it? I don't know, but it was something that would be a slow process. But that's the only one of the so-called tipping points that I see could happen, because, if there's going to be some solid Earth, if the Earth wants to have an earthquake or a big volcanic eruption, there aren't a lot of, negative feedbacks in the Earth system to prevent that. So to me, that's the one bad thing that could happen, but it would take centuries. But the other ones, I don't see it.
So what do you think, when you look at the IPCC reports now and you look 50 years ahead or 100 years ahead, what what would you regard as a credible representation of the so-called climate science? What do you accept the new IPCC prognostications, or do you think the models are so error-ridden that even the hypothesis of 1 to 2 degrees warming isn't reliable enough, even though it's the best we have?
Well, the interesting thing is that the IPCC's Sixth Assessment Report, Working Group 1, they also sort of rejected the climate models to some extent. They were guided by them in their projections, but they also, defined a plausible range of climate sensitivity and looked at the projections from there. So even the IPCC is stepping back from the global climate models as being useful for projections. And people are going to these climate emulators, these simple climate models. Well, for this amount of warming, run it through a damage model or an economic assessment model or something like that. So people are really stepping back from these big global climate models, and it's about time. And one of the innovations that I've been undertaking in my projection work, and this is what I do for clients of my company, Climate Forecast Applications Network, is that I look at it. I don't just look at the IPCC scenarios, and I choose the low-end ones because I think those are more credible, but I also look at scenarios of what the ocean circulations could be doing, scenarios of volcanic eruptions, and solar variation scenarios, and try to put forward a broader range of what we might be looking at. And so I have like a network-based approach to combine all this into producing a much broader range of scenarios. And at least over the next 3 decades, like the natural variability piece of this is pointing towards cooling rather than amplifying the warming. It would tamp down the global warming of whatever magnitude it is from fossil fuel emissions. So that's the approach that I'm taking.